All right, so here's number 3 on the homework review, or the review for the chapter 7 through 9 exam. It's pretty tough, so like I'll try to we'll walk through it and see what we can work out. So we'll just start like we always do with what we do know. We know the mean. Actually, we're going to call this the mean of the sample means, which is this is sort of like the mean of the population. Okay. But we'll use it for the mean of the sample mean here coming up. So 1572. The population standard deviation is 432. The interval size they want us to do is 94%. So I'll just go ahead and put that in there. And we'll see what I do with it in a minute. And then n, little n, for this first one at least is 30, right? That's the number of drivers. So there's our sample size. So here's the problem. So it wants us to determine the interval that will contain 94% of the sample means. And so our sample mean is x bar, right? That's always our sample mean, and that's not given to us anywhere. So we have to use this formula and solve for x bar, and then that will help us. We can if we figure out the z-score of the lower end of this distribution and the upper end of this distribution, then we can solve for x bar at those 2 points, and those would be the bounds. Okay, so let's start by figuring out what z-score we need to do. And so to do that, so if I know the interval has to contain 94% of all the values and it's symmetrical, that means that outside of this interval is going to be 6% of all possible values, right? Because the entire distribution is 1 or 100%. So I'm looking for an interval where we have 94% of it inside and 6% of it outside of that interval. Okay, and so I'm looking for 3% of the data will be out at the top end, the positive side of the distribution, and 3% at the bottom end. All right, so this matters because when I use norm.s.dist, I'm sorry, when I use norm.s.inverse, it wants a probability. So if I'm looking for the top of this distribution, I'm going to say it's at 0.97. So that's the point at which 97% of the distribution is below it and 3% is above it. Okay. And then the z-score of the lower bound, so that's the z-score on the upper side, would just be norm.s.dist. I'm sorry, I did it again. Dot inverse, and that would be 3%, or that would be the point at which 3% of the values are below that point and 97% are above. You could probably already guess that it's just going to be the negative, because we're in z-score, of this one. Okay, so there's our bounds, the z-score of our bounds. Okay, we're going to be 1.88 standard deviations above the mean and 1.88 standard deviations below the mean, and that will take up 94% of all of the possible values. Or another way of looking at that is 3% of the values will fall outside of it on the lower end, and 3% of the values will fall outside of it on the upper end, leaving that 6% and leaving 94% in the middle. Okay, that's kind of confusing, but so now I know the z-score. I need to solve for x bar. I know my mean of the sample means, this number right here, but I don't know my standard error of the mean, so I need to calculate that. my standard error of the mean is always equal to my population standard deviation divided by the square root of n. Oops, I made it extra. There we go. So there's my standard error of the mean. All right. So if I want to solve for x bar, right, if I think of this like a, an algebra formula, in essence, I'm going to have to recast this so that it is my z-score times my standard error of the mean, right? Multiply both sides by that, and then plus my my mean of the sample means. Okay, I don't have any easy way to do that in Excel. I guess I could like just do it, insert a text box. But again, all we're doing is we're doing to solve for x bar. We're going to do this times this, and then we're going to add this to this side, and we'll be left isolating x bar over there. Okay, so for my upper bound, I'm going to say this equals my z-score of the upper times my standard error of the mean plus my mean of the sample means. And that will be my x bar of my upper. My lower, all I'm going to do is I'm going to take my z-score of the lower times the standard error of the mean plus mean of the sample means. It says do 1 decimal. So hopefully this works. 1423.7 and 1720.3. There we go. So now when we want to do it for 40 drivers, all we have to do is update n. And you'll see that as n goes up, our interval narrows a little bit. For 50. And then it says explain the difference in these probabilities. So increasing the sample size, blank, the standard error. We didn't look at that, but let's just go back to 30. Look at our standard error, which is 78. Then when we go to 40, it goes to 68. Then when we go to 50, it goes to 61. So increasing the sample size decreases or reduces the standard error. This in turn blank the probabilities that the sample mean will be closer to the population mean. And we're going to say, I think they want us to say increases the probability that the sample mean. I don't know if I like their wording, but let's see. Yay. And that's it. So hopefully that's helpful to you. And good luck on the rest of the review and the exam.